Okay, so now I'm going to start the new kind of the data structure, that is the tree data structure. In a general tree, you can understand a tree is a non-linear hierarchical data structure that consists of the nodes connected by edges. Over the slide, you can see we have the 1, 2, 3, 4, 5, 6, 7, 8. These are the different labels I have given to the various nodes. And you can see easily noted down in your mind, that is the it is a representation like a tree. So the in the tree manner we can represent our data, but at the time representation of data in form of the tree. So what kind of data structure we have? We can say we have the tree data structure. When we have the data structure in the array manner, so we are much familiar about that part. The stack manners means, when the stack means first in first out, and last in first out represented by the stack, and first in first out represented by the queue, as we know, and this part we have already discussed so many times. Linked list means we have a data structure that can be represented by the two different parts. And why we are going to the linked list? Because the dynamic memory calculation can be utilized in perfectly manner. So we have the linked list. So with help of the linked list, we can represent our data into the two manners. One is the data part, and another one is the address of the next node. So that is recognized by the node. But here we have the node that is represented by the different labels, and each and every part represented by the in general form. So we have the general tree. We can represent our data into the linked list manner. So that is known as the linked tree, just like the linked stack and linked queue. But before understanding the linked tree, we will understand what is mean by the tree itself. So I'm starting my this point over here. That is general tree.
करोड़पति हो गए हम, रातों रात करोड़पति। हाँ, कैसे 25 दिन में करोड़पति। करोड़पति 25 दिन में। कोई गांव से आया हूँ क्या?
A request to each and every student, please mute yourself, because I don't like this kind of disturbance. Please avoid this thing. Okay, so this is my first slide. As you can see over here, that is a general tree. So as I discussed you about the general tree means we are talking about this kind of data structure, and you must have some idea about what is mean by the tree. And this kind of the institution, you just this kind of the diagram you have seen into the various places. Representation data can be recognized as a tree. So 1, 2, 3, 4, 5, 6, 7, 8. We have the labels of the general tree, and this is why I'm just taking general tree, because this is a general tree you can draw anyway. Like example, I'm just drawing a tree, and that could be a tree definitely, but a tree has its different meaning, and tree just having the different kinds. So we will see one by one. Like example, I'm just taking a tree that is a a is our root node. Here we have another point, a node that is a B. Here I have another node that is a C, and here just I can have the another part that is a T. Okay, so I'm just drawing only the its left part. I'm not going to the its right part of the root. So we can say this is also tree, but this is also represented by the only tree only, because we have the various kind of tree. So we can't say this is not a binary tree or different kind of tree. So we will see one by one. So this is this idea about the general tree. So what is the representation data you can have into the tree manner? So that is a representation. Now is this clear all to this part? Because we need to aware about some terms. Those are consist of the nodes connected by edges. So what is mean by the edges? This A and B are connected by the some part, and this part is recognized as a edges. Now, this part is clear to all. This part is clear to all. What is mean by the tree, and how to represent tree into the data structure. Theoretical part is necessary to understand. Is this clear to all?
Yes, sir.
Okay, so I'm just moving to my slide. So theoretically, you can read out over here. I'll just give them here to notes purpose, so you can read out. A tree is a recursive data structure containing the set of the one or more data nodes. So as you can see into the previous slide, we have the more than two data nodes, when each and everything represented by the connected way through the its edges. So where one node is designated as a root node of the tree. So as I told you, while remaining nodes are called as the children of the root. So you can see over here, A is a root. If A is a root, okay, or you can see over here the if this node is like a root. So other other one are represented by the its child or children. If there is one node, one node other than the root, so we can say it is a child node, or we have the multiple, so we can have the children. So one is our root node which have the two children, one is a two, and second one is a 3. So we can say 2 and 3 just having its parent nodes that is recognized by the, or that is labeled by the 1. Same here we can have the to have the two node is just having its two different children, one is the 4 and 5. So we can say the 4 is a child node and 2 is a parent node, and here we can have the 5 is a child node and 2 is its parent node. So two just have the two is having by the its two children, one is a 4 and 5. Same here we can have the 5 which is its parent node of the 6 7 8, and 6 7 8 are the children of the 5 nodes. So we can say these are the representation of parent or child relationship, or we can say this is the hierarchy of the parent child relationship. So the nodes other than the root node are partitioned into the known empty sets where each one of them is called to be subtree. So this part you can understand over here. Now look here, I'm just drawing over here. So this is look like as a subtree. Now please keep in mind this is a look like as a subtree, and if this is part of, we can say this is a kind of the subtree. A tree can have a subtree, and that is recognized by the left subtree and right subtree. So we will see this part into deeply manner while studying the binary tree into deeply manner. Yeah, this one. So the nodes, other than we have seen, this is the what is mean by the subtree, and a sum node definitely. And nodes of the tree either maintain a parent-child relationship, as I told you, between them they are also sister node, just like this one. 2 and 3 both are the node which is represented by the brother and sister of each other. So these are recognized as a sibling. Okay. 2 and 3, these are the two different nodes, and 2 are the different 2 and 3 both are the different nodes recognized as a sisters and brother and sister of the each one. So we can say these are the sibling nodes. These are known as the siblings. So I can write the spelling over here, SIBLING. These are the nodes of the sibling nodes. So here siblings we can write. And 4 and 5 is also here are the sibling. And 6 7 8 are the sibling of each other. So here we have the sibling nodes. So what we have the different kind of nodes? We have the root node, we have the parent node, we have the child node or children we can say, and we have the sibling node. So four kind of the nodes we can have into the our into a single English or say single a tree. A tree can have its various nodes recognized by the root node, parent node, children node, or child node if there is a one node only, and we have the sibling nodes where we have the multiple siblings, so we can have the siblings node. Now this part is clear to all. What kind of the node we have and how to represent the 50. Now this part is clear to all. Is this part clear to all? What is mean by the tree and what are the various kind
Yes,
of the
sir.
node? Any doubt you have, then please ask. Because on the basis of this kind of the fundamental, we will sort out the our different kind of problems into the coming classes. If we must aware about the different kind of the terminology, and that is necessary: root node, parent node, child node, and sibling node. Okay, and sibling node is also known as the brother node or sister node somehow. So I'm just coming to the basic terminology. So basic terminology, we have seen the root node, subtree, we have seen leaf node, definitely last node recognized by the leaf node, and path, and center node, and degree, and labels. This is a basic terminology we will discuss one by one. So I just given into a theoretical. This theoretical is just related to this diagram. So you can see over this diagram that A is a root node. So T1, T2, T3 are represented by the its various subtree. So B and C and D also recognized by the uh, children of the A node, but B and C and D are the parents of itself, and EF is the uh, children of the B. So we can say B just represented by the subtree. So we can divide this part into a different manner. So how to represent all this part we will see into the one by one. But here we have the little bit not easiness of the diagram. So what I have done, I have just taken the diagram from the various sources into the single manner where you can learn each and every things into the easy way, and clearly neat and clear diagram you will understand. So rather than understanding the all the concepts into a one diagram, we have the different diagrams to understand each and every one, each and every term in clear manner. So I'm just directly focusing on the my next part, that is the tree terminology one by one we will see rather than do the single slide. Now, okay, this node. So what is mean by the node? Node, if anyone asks you about the node, so node basically is an entity that contains the some key or value. That could be represented by key or value means we have the some data, and it just point the its child node. How we can say represent the child node? So that means represent by the representation of the node can have the its two parts. That could be more than two parts. Like this is a root node. A root node just pointing to its two different part, that is a left part and right part. So I can say I can draw the node diagram over here. A node can represent it like into the implementation part, that is if I'm implementing one. So okay, this is a root node. Okay, this is a root node. If I need to design the node diagram of the root, so I'm just like taking example root node. Rn means my root node. So the value of this represented by the one, and the address of the two, that is recognized as the left part, and this is known as the right part. So left part, that is the left part means representation by the address of the second node. So it will give the address of the second node, address of the two, and same thing it is representation by the address of the tree. So we can say a node in a tree can have the three parts that will be recognized by the em value and address of the second address of the left subtree and address of the right subtree, we can say, or right node or left node. So the last node is always represented by each path. So I just coming to the my point. So pointer its child node, as you can see, as I told you over here. So two and three are the children of the one. So one is our root node, and the last node of each path is called the leaf node, and that is known as the external node. So here 4 and 5, here 4 and 5, these are the leaf node. These are recognized as a leaf node. These are known as leaf node, and these are also known as the external node. Why these are known as external node? Because after these nodes, there is no, or this node is not connected to its ahead node. So definitely these belong to the last node, and so they are recognized as a leaf node or external node. And definitely, and after this, you just try to represent any information you can't represent, because last value of the value can have the 4, but the next part of the this node definitely will be the null in form of the practical, we can say. So there is no connection between the other nodes. So because they represented by the last node, like the linked list. So 4 and 5, these are recognized as a leaf node or last node. So extend do not contain any link or pointer, as I told you, into the child node. So definitely it's represented by the last node. So what happened at that time? If I'm just taking the example of the fourth one or fifth one node. So last node or address of the next or address of the left subtree and right subtree will be the null. So that's why these are the known as the external node or deep node, because there is no connection between the other nodes to these nodes. And the node having at least one child node is called internal node. So definitely the question comes in my mind, that is, we are talking about the external nodes and what is mean by the internal node. So internal node, you can say you're a node which is having at least one node. So like true node. Okay, this is the one. So one is a root node. It's having the one node. So this is also recognized as an internal node. 2 and 3 also recognized as the internal node. No problem. But here these three is not a internal node, because this three is also a leaf node, because no connection of its ahead node. So we can say 2 and 3 are the sibling node, but 3 is a leaf node. It is not an internal node. It is recognized as an external node because there's no more node is connected to its one. So definitely it is recognized as a leaf node. It is not a internal node. Now question comes in one, so what do you mean by the age? So age means the linking between the or linking parameter by which we can connect. So there is some relationship between one and two, and how we can make a relationship. So those are recognized by the some term that is known as the age. So here the node and age is more important part for making a tree. Okay, so you can see over the diagram that is a this is recognized as a node and this is recognized by the age. On this slide, you have any problem, then please you can ask me. Do you have any problem over here? What do you mean by the node and what do you mean by the age? Because we will see the algorithm of the tree one by step, but before jumping its algorithm, we need to understand some basic terms. Is this clear to all? What do you mean by the node and age? Or should I explain once? Here,
Explain the
Yes, sir.
yes, staff, tell me. Should I explain once or is it clear to all?
their edge part.
Last one. Okay, I'm just explaining one by one. Now, suppose I'm taking here. Uh, okay, this is our first node. Are you agree with this one? Please communicate me properly. This is our first node. Can we
Yes,
say
sir.
this is a root node? Can we say this is root node?
Yes, sir.
Please understand the theoretical part each and every one. So please contact me and communicate properly so I can understand you are gaining or not. This is our root node. Okay. Is it clear to all? You say yes or no. That's why
Yes,
I
sir.
can understand. And here we have only a single node, so we can say this is a leaf node or this is the external node. Can we say? Because there is right now we have only a single node.
Yes, sir.
Okay. Now we have another node that is a B node, and B node is connected to its left part. So we have the B here, and we can say here we have the C. So this is a root node, and this is also known as the parent of the B and C. Okay. Now is this part is clear to all? Is this clear to
Yes,
all?
sir.
Okay, so we can say A is just having the its two children, and those are B and C. Okay, so B and C are not connected to more nodes, so we can say this B and C are also recognized as a leaf node right now, and A is not a leaf node because A is a internal node we can say, or A we can say it is a root node right now because it's the first node. So B and C is just not an internal node. Right now it belongs to the external node because there is no more connected to its. So we can say A and B is a our external node or leaf node. Now I'm just connected to more over here D, and for I'm just taking the here E. Here I'm just connected to the F. Here I'm just connected to G only. I'm just taking right part only, non required. Okay. So here, just root node. I'm just writing over here. What are the root nodes? So root node you can say over here. Those are there will be the one root node. So that is the A is a root node. Okay. Now tell me the first. Tell me the leaf node. Please tell me the leaf node. What are the leaf nodes? Please tell me. What are those?
EFG.
Good. E, F, and G are the our leaf nodes. Because ahead of these nodes, we don't these nodes are not connected to other nodes. So these belong to the leaf nodes. Definitely true. Thank you. And what are the internal nodes we can say? Internal node we can say
BC.
internal node. Definitely. uh, B, C, and D. D is also internal node because at least one node must be connected to its node. So D is connected by one node. So E. So we can say D is also internal node. So we can have the B, C, and D. Okay. Now, is this clear to all?
Yes, sir.
So root node, we are much familiar about the root node. Please keep in mind that there will be the only single node, that is single node. Root will be always represented by the single, and other belongs to the parent node and child node. Okay. So internal node we have seen, and diff node. And if someone asks you questions, what do you mean by the parents node? So how many parents node we have? So definitely C, B, and D also recognized as a parent node of its tree, its subtree we can say. So D is a parent of the E, okay, and B is a parent of the D and F. So C is a parent of the G. So that part you need to take care in mind. And G is a child of the C, and B and D, sorry, D and F is the children of the B. Now question comes about what is meant by the sibling node. So sibling node you can say what are those sibling nodes? Please can anyone just explain what are sibling nodes? Sibling node. If I ask you to the question, what is mean by the sibling node? What are sibling nodes over here we have? Please tell me.
Sir, the
D,
yes, sir.
yes, yes, D and F. Okay, thank you. What happened? C node just having a one child, and there is no brother and sister of this node. And B just having the two children. So we can say D just having its brother and sister, that is F. And vice versa, we can say F is just having its brother and sister. So we can say directly D and F both are belong to as a sibling nodes. Okay, is this clear to all? Please,
Excuse me, sir.
yes, just tell me.
Sir, B and C are also sibling nodes now.
Yeah, definitely. That's the point I'm asking. So the sibling nodes we can say over the for the B node, how many sibling nodes we have? We have the D and F. And for the root node, we have the two siblings node, those are the B and C. So based on the its level, based on the its height, and those part we will see into the coming part or coming slide. Definitely for the root node, there are two sibling nodes, those are the B and C. So we have also the sibling nodes B and C. So B and C are the sibling nodes, and D and F both are also sibling nodes. Okay. Now this part is clear to all, or any doubt over here? Yes, please speak up or say yes or no so I can understand.
No doubt, sir. No doubt.
Okay, is this clear to all? So shall I move ahead?
Yes, sir.
Okay, I'm
Yes, sir.
just so here we have a very stern so you can understand a tree with 11 nodes and 10 edges. Okay, so that part you need to identify so you can just find an easy way. So there is a simple idea. If we have let me change the my color pointer first. Yeah, right. So tree with 11 nodes and 10 edges. So how we determine? So in any tree with we have the n nodes. So definitely the maximum number of edges will be the n minus one. And this is very simple idea, simple point or key point you need to keep in mind. Suppose we have the n number of nodes, then how many maximum number of edges we can have? That is the n minus one. So tree with 11 nodes and 10 edges. And number of nodes and number of edges can't be equal. So this point you need to keep in mind. So this is represented by the edges. So one, okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of edges we have the 10, while number of nodes represented by the 11. So you can start A, B, C, D, F, G. So total we have the n number of nodes. Those are A, B, C, D to up to IJK. So we have the n number of nodes. So that is a 11. So how many edges, maximum number of edges can be represented by all these nodes? So we can have that is a edges equal to n minus 1. So it is 10. So this key point you need to keep in mind while solving any problem into the coming classes when we try to learn about the nodes and edges calculation. So now is this part clear to all? This point you need to keep in mind. So if we have the n number of nodes, then how many maximum number of edges we can have? So that is n minus 1. Okay, is this clear to all? Please speak up so I can understand you are gaining or not, or is it this slide is visible to or not? Okay, this part is clear to all. This point you need to keep in mind. If we have the n number of nodes, then there will be maximum number of edges n minus 1. That is a 10. If we have the 11 nodes, is it okay?
Yes, sir.
Okay.
Yes, sir.
Okay. So the point we have over here, the topmost element, the topmost node is represented by a tree, and I'm speaking again and again. So because we are we must be familiar about the basic terminology of a tree, because tree is having the lots of the parts. Those could be parent node, child node, sibling node, leaf node, root node. So a tree can have the various components. So each every component it is necessary to understand, and we must be aware about the labels, height, and so many things. So one by one we will understand, try to understand. So root is the topmost node of the tree. This part we are familiar with this part. The question comes in a moment that is what is mean by the height of a node. So the height of a node is a number of edges. Please keep in mind this point. The height of a node is a number of nodes from the node to the deepest leaf, and that is the longest path from the node to the leaf. Okay, so that you can understand by the this part. So height can be represented by the 2 and d represented by the 0. What does it mean by? T means we need to say it's deep. Deep means we can say it is a level. It is also recognized as a level, and it is also recognized by the depth. But before jumping its head part, we must understand about some theoretical part. Height is equal to how to determine, and d is equal to 0 how you determining, because at the very beginning there's no depth because you are on the platform, so you are just going to the downside. So then definitely we are jumping to the our first level or two level. So we can say definitely depth will be the 0. So depth can be understood by the number of edges from root to the node. So definitely how many edges are connected at the root? How many edges? How many edges? No edges. Is to connect it to its root. So definitely depth will be its 0. And here we just jump to the over here. Suppose after coming over here, this node, it is noted down that one node is this node is connected to its roots. So how many nodes is connect? How many edges are connected? One edge. So we can say it is just having the it's just having the one depth, and we need to keep in mind, we need to identify the depth of the node, and we need to see how many edges are connected from its root to its. So where can say root to its connection is recognized by the number of or the value of the depth, and that is recognized by the number of edges connected. Here we can say D will be the 2. Why? Because this node is connected by this node, and this node is also connected by this node. So we can say from root to this node we are having the two different edges. So we can say it is represented by the its depth is 2. Here we can also having the same value. Definitely this depth will be the 2. Same thing we can easily find over here. So depth will be the 1. Undoubtedly there is no problem. But now question comes in our mind, so what is the height of the tree? So height of the tree can be represented by the height of the root node from the depth of the deepest node. So reverse part of the depth node calculation we can represent it by the height of the tree. So here we can say what is the height of the node over here. So definitely it is very lowest part. So leaf node always represented by the height node that is equal to 0. So here we can say height will be the definitely will be the 0, because there is no height over here. When you need to measure the height of the its upper node or its parent node, so definitely its parent node will be the represented by the 1. So height will be the 1. And if we need to see its subparent, so by what is very basic idea? You just need to understand through the age calculation, or you can just try to add one more value. So if you need to find the height of its upper node, so if we need to measure the height, so height can be represented by one over here. It is okay. But if we need to measure the height of this root node or this node, so what is the previous height of that is the 1, and you are jumping its previous part of previous node, so we can say 1 plus 1, so we can easily clear that height of the root node or height of this node will be the 2. So indirectly we can say the height and depth are the inversely of each other. This is a basic term you need to keep in mind. Okay, now is this clear to all what is mean by the height and depth, how you can measure, or if you have any problem over here, please you can ask me.
Sir, height of the tree, sir. Once again.
Height of the tree, okay, it's very easy. So I'm just okay. Let me take the another example for you betterment. Okay, I'm just taking the A is a variable, so node B and the C. I'm taking only random nodes. Okay, so you can take anything. E can't be duplicated. So A, B, C, D, E. So this could be F. Okay, this could be G. And what I have taken over, I have drawn a tree. A just having its two part. Okay, two children, B and C. Sorry, B and F. And F is just having the its children. I'm just please see. I'm just drawing on the left part over here. I'm just drawing on the right part only. I didn't take even I didn't take only the left right, or it doesn't mean, because it is a general tree I'm taking over here for understanding the basic concept. You can also take, you can also draw like over here. I'm just taking the dot manners. You can see, you can take like over here. So it is clearly mentioned that this F node is having the two sub nodes. Okay, and two different nodes, so those are recognized by the two children, we can say. And so I and G is just having the sibling. So I'm not counting over here with just only the understanding purpose. I took only the node. So tree representation could be anything, but few things we need to keep in mind what kind of tree we are having. So basic on the tree types is a most important part. Okay, I'm just moving to the my next part. Now I'm just taking the another color for the betterment explanation. Just change the color. Yes. Now, first, what you want? You want to height or depth? Let me clear to all. What do you want first?
Sir, height of a tree.
How the height of a tree? So definitely, height of the tree will be measured by the from its leaf node. So height of the tree will be the its 0 at the beginning. And if you need to measure its height, so that is a D node. The height of the D node can be calculated by the its previous node. So how many nodes connected here? Only the one node. And how many is here? So definitely one. Don't look this even. Don't look this part. Sir, the two nodes are connected. Two edges are connected. So we can say the height of this node will be the 2. No, height of the nodes means from leaf node to its upper part, its upper node, we need to see its edge. So definitely E is connected to its one. So height of this node will be the one only. Please do not look at the number of nodes, number of edges is not a part of the calculation of the height. We need to see from leaf to its level, and that is recognized by the its level. You're jumping. So if I'm just truly speaking, this level is represented by the 0 level. This is represented by the its 1 level. Initially, we represented by the level that is 0, and 2 and 3 and 4. So we can say these there are different levels of the each and every node. The root node is always represented by the its label, that is a 0, and B and F, these two nodes are represented by the one label 1, and C and G is represented by the 2 label, and D is respectively we have the 3, and E is represented by the 4 labels. So based on labels we need to keep in mind. So what happened? H is just represented by height. So height of the any node will be calculated by the from its leaf node. Okay, so height of the leaf node will be the definitely will be the 0 always, and its upper part represents the 1. So if we need to calculate the height of the C node or height of the second level, we have the C node. So how to calculate? So previous height, that is the plus 1 and plus 1. So you can add over here. So you can see 2. Same here we can say we will have the 3, and root node is having the height, that is being calculated by the easy way. So we have the 4. And depth part you can take into from the reverse manner. So the depth will be of root node will be the 0, and same you can mention over here. Okay, so 0, 1, 2, 3, and 4 we have, and depth you can see of the E node, that is a 4. So this is the height and this is depth, and F node is just having its height definitely. This is just this is 0, and this should be always this should be 1. Yes. Any problem over here? Any problem is over here, then you can ask me.
No, sir.
But I have a question. That's why I'm saying. You must have a question, sir. After calculating the height of each and every node, so it is noted down over there. Okay, it is noted down over that. Okay, depth is easy to calculate. No problem. We can do. And we have taken the height over here, that is the 4. We have calculated from the left part only, the tree. And if we're talking about the right part, so if it taken or we just try to calculate the height of the tree from its right part, so we can say the height of the tree will be the 2. But we have taken the 4. Why we are taking the 4? Why we are not taking the 2? This is the big question I have. Because left side I just calculated, no problem. And but from the right side you will take definitely height of the root will be the 2 only. But I've taken the left part, so height of the root is 4. So now here I have question. So why we are not taking height of the 2 or we are taking the 4? Please, anyone just can give me idea. Please speak up and tell me. You are much familiar about the answer. Please, anyone speak up. Please do fast.
So usually the height means from the root to the farthest distance.
Farther distance or deepest, definitely we can say, because as I just told you, the height of the node you can just note down deepest node. Okay. So whatever I'm putting into the form of the content in form of the nodes for your betterment, that's why I'm putting over here. Because when try to learn the definition of some nodes or some points from the slide, you will understand what I mean to say that over here. So height of the tree definitely will take from the deepest. Okay. So you can see over it as well over here. The height of the tree, height of the this tree or this node, we can easily determine that is 2, not the 1. Okay. So why we are taking the 1 and 2? So this part we can understand. Now same thing you can. So definitely when I will give you any example here, and I just give you any tree for your easy question for finding the height and depth also, you definitely if you student write height will be 2, not height of the 4. That part you need to keep in mind. Height of the tree will be counted from the its deepest node, and that is a node we can say the deepest of farthest leaf node. Is it clear to okay? Now this part is clear to okay? Clear to all?
Yes,
Yes,
sir.
sir.
Uh, Now, if I give you any question regarding the tree, just find the depth of the node and find the depth of the root or depth of the or height of the root. So you can easily calculate it. So now everyone will not do kind of the any mistakes. Okay. So shall I move ahead?
Yes, sir.
Okay, so I'm just jumping to my next slide. So A is a root node. So in any tree, the first node is always recognized as a root node, and in any tree is connecting the link between the two nodes. So from my slide, definitely from my this PPT, you will see all the diagrams where you can learn some lots of things about the basic terminology of a root of a tree. So root and edges, we have just familiar with this term. So I'm just skipping the slide. Now here height of the tree is definitely will be 3. How to calculate it we have done. So from this picture, from this diagram, you can see. So in any tree, height of the node is total number of the edges from the leaf. So that node is longest, definitely or farthest. And in any tree, height of the tree is height of the root node. So you can easily calculate in anywhere. So height is a 0, height is 3, height is 2. So each and every node is just having its height. So again, I'm just moving to another slide because this part we have already covered through an example. So the depth of the tree you can easily calculate from the root to last node. In any tree, depth of the node is total number of edges from root to that node. Okay, point you need to keep in mind, root to that node, or if you have talking about the height node, so edges from the leaf to that node to the longest part. So that point you need to keep in mind while writing the any definition or any point into the examination about the question. Or in any tree, definitely depth of the tree is always total number of the edges from the root of the leaf in the longest part. So these two different concepts, height and depth measurement calculation, we have already discussed. So here just a few points in from an easy manner, and those part we have already covered. But let us have some idea, more idea about some other nodes. So those are the parent node and child node. In entry, the nodes which have a child or children is called the parent node. So as you can see, A is the root node and B and C and G, E. So here B, C, G, E are the parents node, and this part also we have already covered. And here you can easily note that B, C are the children of A. So theoretically, it is clearly mentioned over there. And H, G and H are the children of the C. Okay, this part we also covered that. So this is also we can see. Okay. C is a parent and G is H are the children of the C. So C is a parent. Okay. And K is a child of the G. So definitely we can say which node is a parent node and which node is a children node. So we can easily find out. So without any problem, we can easily find out. Now, ages having the two children B and C. So this is also I'm just putting into a single box for understanding purpose. So A just having the two children B and C, and C and B are the other children of the A node. So A is a root node here, so it is a parent node. G and H. So who is the or which node is a parent node of the G and H? So easily determined that it's a C node. Okay, so this part you can understand from here. Now, is it necessary to explain more about this slide, or should I move ahead? Is it necessary to explain more detail about this slide because this part we have already covered?
No, sir.
So shall I move ahead because this part we have already covered? Shall I move ahead?
Yes, sir.
Okay, okay. So now this part. So here you can see the sibling nodes are colorized into different color B and C. B and C are the sibling nodes. Okay. D, E, F again also sibling nodes. G and H also sibling nodes. I, J also sibling nodes. K is not a sibling node because there is no brother or sister of this node. Because G is a parent of the K node and G is just having only the one child. So a K can't be sibling. Okay, so this is theoretical parts we have already seen. So I'm again jumping to the my next step for the next concept, and that is known as the degree. So let us understand the degree. So what is mean by the degree of a node? So degree of a node is basically represented by the total number of branches of that node. Okay. total number of branches of that node, so we can represent that is the degree. And forest, a forest means a collection of disjoint degree is called a forest. So here we have the different examples, and then you can learn that what is mean by the degree and what is mean by the forest. The first diagram, first part we have, but these two examples we have over here. This is a simple example. This complete example represented by the forest only. Okay, and how we are transforming this tree into the forest, and that is a necessary part. The forest can be understood by the collection of disjoint tree. Okay, so A is root node, so this is a tree, or we can say it is subtree of the root node because it's connected. So I'm just disconnecting. Okay, and definitely C will be itself is a separate. So these are represented by the forest. Okay, so forest means collection of disjoint tree. So how many sub trees we have by which we are making a forest? So with the help of these nodes, or we can say this is a tree or subtree, and itself is a node. So we are making a tree. A tree, you can say, a collection of the disjoint tree is called a sub. We call it forest. So how to calculate, how to measure a forest? So we have a diagram, but before understanding the diagram, we must have some idea of the definition part. So degree of a node, if you need to measure, then how you can measure a degree of a node of the total number of the branches of that node. So can anyone just here give me idea how to calculate the degree and what is the degree of this tree? Please, can anyone give me idea what is the degree of the 4 and 5 and 2? Okay, I'm just putting a question. What is the degree of the 2 node? What is the degree of the 4 node? What is the degree of the 5? Please, can anyone just give me idea?
So
Can
degree
you?
of 4 is 0 and degree of node 2 is 2.
Degree
Okay, okay, just
second node is 2
okay.
and
One
4 and
second,
5.
one second. Degree of 4 is 0, and degree of 5 is 0, and degree of 2 is 2, as you are speaking, okay, and a degree of 3 is 0. So is it correct or not?
Sir, branches,
That's the point you need to keep in mind. First, that is a branch. So what is branch? Okay, now question comes in our mind. This is a node. So how many nodes are connected to this node? So this is represented by its branch. Okay,
3 nodes, sir.
so definitely. So two is a node which is having the its two branches, and that is the 4 and 5. So because it is connected by the two different nodes. So definitely, just 2 is represented by the its total number of branches is 2 we have. So degree will be the 2 itself. This is the correct answer. Is it? But it is very what I can say is very easy concept. So into my next slide, I have a very simple example where you will see this concept in easy way, and later on we have the course example. So I'm just moving to my example over here, then you can understand. Now, degree of V is 3. Degree of V is 3, how you can say? Because it is connected by its three different nodes, D, E, F. DEF. So we can say in general way or in the tricky manner we can say a node, how many children of a node can we understand by its degree. But it's a children, not so it's a parent, it's a grandchildren we can say. We can't count the grandchildren. We can determine only the children only. So we just having the three children DEF. So we can say it's just having the three degree, or we can say it's branches. So how many branches connected by the one branch, two branch, and three branch? So we can say degree of B is 3. Same thing, A is a root. So how many branches it have? Two branches. One is going for the B, and another is going for the C. So degree of A will be 2, and leaf node is always represented by the degree that is 0. So the point we need to keep in mind that is what where is f? F is here, so degree will be of f will be 0. And somehow I can speak over here. Degree of a node is total number of children it has, as I spoke. So when anyone asks the question, what is mean by the degree, then you can easily determine that is what is mean by degree. So you can easily calculate the degree. So now this part is clear to all that how to calculate the degree of a node in a tree. Then can you explain? Okay, is this clear to all? Please let me know.
Yes, sir.
Okay, so if I ask any question regarding this degree, then you can explain. Okay, so I'm jumping to the my next slide, then you can understand. Okay, now the question comes in our mind, sir. What is mean by the subtree and other thing, another part? Okay, so you can explain. So here I have a very simple example. Previous diagram we have that is this diagram where you can see A is our root node. So where we can divide the some parts and those parts recognize a subtree. And this is a tree. And this tree is divided into the sub different parts, so we can say it is a subtree. A is our node. So subtree can be recognized by the this part is recognized as subtree and this part is also recognized as subtree because it is also having its own children. Here we can say it is having its own children. So definitely we can have two subtree. This is also known as a left subtree. That part you will see to the coming classes. That is also known as a left subtree, and this is also known as the right subtree. This is also known as the right subtree. So definitely any tree in a tree we can have the two different tree that is the left subtree and right subtree. So here we have the left subtree and right subtree. And left subtree and right subtree concept you will see into the binary tree, but right now we have the general tree, so it can have the many branches. Please keep in mind if we're talking about the any normal tree or general tree, so it can have the many branches. So here B is a B node or B is a parent of the D E F. But in the case of the binary tree, only the two node will be applicable, left node or right node, or two subtree will be recognized that is left subtree or right subtree. Here we can also add one another tree or another subtree. So here we can't say exit left subtree or right subtree. So this is the right now we are understanding on the general tree, but into the case of the binary tree, we can have only the two part, left or right. So that part we will see in the coming classes, but before understanding all those concepts, we need to understand what is mean by the basic general tree. Now, is this okay? Is this okay? What is mean by the subtree and what why we are saying it is left subtree or right subtree? And if you have any question over here, then you can ask. Is anyone having question over here? Is
No,
anyone
sir.
have is anyone having any question over here? What is mean by the degree and the things?
No.
Okay, so I'm just moving to the my slide. Now, question comes in the moment, sir. We are talking about different kind of a tree. So definitely we have a different kind of a tree. Tree is divided into a different kind of types. First, we have the general tree. So about the general tree, we have discussed lots of the things, and in this kind of a tree, a general tree can have the many. General tree can have the many parts. Many parts means many sub branches. It can have the main tree. But we are talking about the binary tree and the binary search tree and the two-normal tree and expansion tree. So it has its own meaning. Okay. But if you're talking about the forest, so forest means a disjoint, a collection of disjoint subtree or tree is known as a forest. So forest we will discuss later on, but right now we are discussing about the more about the general tree and other kind of tree we'll see. General tree and its basic terminology we have discussed, and those are height, depth, root, parent node, child node, sibling node, leaf node, external node, internal node, and degree, and different concept of the regarding this kind of tree we have seen into the from the terminology. Now we have the one by one. The general tree. The theoretical I'm just giving you for betterment, then you can have. Okay. So here theoretically you can read each and every point where in form of the notes purpose I'm just giving. Okay. Here I'm just putting the content over here for the notes purpose. So here in the general tree you can understand a few terms like level 0 is basically represented by the root elements, and there is a relationship between the parent-child relationship we can see in this part. Whenever we have a subtree, two subtree, it's okay. But when we have the three subtree, like like here, is it subtree? So I'm just making another content like Z. Okay, and it can have the W and it can have the X to third. So how many subtree it has? It's having a three subtree. So we can say this is known as the ternary tree. So we have the ternary tree, but right now we are not talking about ternary tree. So this kind of example you will pay in general tree only. Binary tree means we can have the it's having only the two subtree, that is the left subtree and right subtree. So that part we will see deeply manner, but before understanding that part, we need to understand the few basic terminology which is necessary to understand what are the various type of the tree. General tree can have the various subtree as well. Like example, A. It can have the many branches without any problem. B, C, D, D, E. But in the binary, only the it will be the only the two subtree like B and C. I'm just taking over here only. So binary is represented by the binary. Only the two subtrees applicable over here. And based on the binary, we will implement the binary search tree. And what is mean by the expression tree? So we will see this part today itself. And the definition of tournament tree we will have. So today we will cover the expression tree and tournament tree in simple example. Binary tree and binary search tree we will see into deeply managed followed by some algorithm as well. And forest is basically a definition purpose only. So it's a disjoint collection of the various trees known as the forest. So generally we have seen into the various terminology as well. So right now, theoretically part we have binary tree and binary search tree we will discuss into the deeply manner. While discussing the binary tree and binary search tree in deeply manner, we will have the two or three slides as a form of the review about the this tree. So before jumping the binary tree and binary search tree, I have only the uh, expression tree and forest. So let us understand the just definition idea about the forest through the diagrammatic manner. So you can have over here. A is a, what A is our root node. A is our root node. So how many we can say how many subtree just having by this node. So A is a root node and this is a general tree, and this general tree also recognized as a ternary 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 tree. Why it is known as ternary tree? Because it is represented by the three subtree, and those are, please keep in mind, those are, this is recognized by the one subtree, and this is only the one node only we can have, and this is only the third tree. So how many subtree we can have? One, two, and three subtree we can have, and those are recognized by the forest one, forest two, and forest three. So how did you find this? This is a forest because this is disjoint. So what happened? Just I'm just removing its node from its various subtree. So after removing the node from its various subtree, so finally we have the various part of the uh, tree, and those are recognized by the forest. So forest can be defined as a set of disjoint trees or trees which can be obtained by deleting the root node and the edges which connect to root node to the first level node. And this is the actual definition what I am speaking over here. This is the actual definition what I am speaking over here. As I told you, this is the forest. This is the forest definition. You can. What's basic simple idea? Just remove the nodes and its edges to connect new edges. So finally we have the different parts. So finally we have the forest, and this is the forest. Okay, now this forest is clear to all, or should I explain by the another example?
So clear, sir.
Is forest is clear? So okay, now forest is clear too. And theoretically binary and manifest tree I'm skipping right now because we will see this part into deeply manner. So general tree is clear to all. What do you mean by the general tree? General tree can have the more than subtree. Okay. Now this is not a binary example. This is a general tree example where we have the three subtree. Okay. So this is also known as a ternary tree. This is example of a ternary tree. Okay. Now forest is clear to all. Please tell me. Forest is clear to
Yes, sir.
all. So I'm just okay. Just moving to expression tree. Now, expression tree is basically used to evaluate your expression followed by the tree man. So, expression can be used to evaluate the simple arithmetic expression. Expression tree is basically a binary tree. Now, keep in mind, expression tree is a binary tree where internal nodes are represented by the operators, while the leaf nodes are represented by the operands. Please keep in mind all the points for understanding the expression tree. Expression tree are used to evaluate the simple arithmetic expression. That point you need to keep in mind. As the name says, expression. So expression tree means we have the our expression from the tree, so we need to evaluate. And expression tree is basically a binary where internal nodes are represented by operators while leaf nodes are represented by the operands. That point you need to keep in mind. All leaf node always represented by the operands only, and operator just used as the internal nodes, and that could be the parents. We can say definitely. An expression tree widely used to solve algebraic expression like a plus b into a minus b, and consider the following example. That is a plus b and divided by the a into b minus c plus d. So keep in mind, as we know, while solving an expression, we need to look the our this example from the tree and how you are doing this activity. So can anyone solve this question? Can anyone solve this question, or should I solve this question? Can anyone solve it, or just should I solve this?
So which question, sir?
This can you solve this equation to this tree? Because that example you have, just see this example and see this example and understand this example within 1 minute and tell me how we are evaluating. So did you understand what is going on and how we are evaluating this expression?
Yes, sir.
So please explain.
Sir, first of all, we are giving preference to the brackets
Yeah,
operation, sir.
definitely. Okay.
So we are starting from that A and A plus B section. So as we have discussed, sir, the root node would represent the operand. So the plus will be the root node of A and B.
But just 1 second. I'm stopping over here. You are going to the right direction. The first point you need to keep in mind. Please keep in mind this point. Expression tree is definitely we are using for evaluating the arithmetic expression, but representation of this tree will be in form of the binary tree. Okay, so it means any internal node will having only the two node only. It can't have the three nodes. Okay, it can have maximum two nodes because representation of this kind of tree will be in form of the binary tree, and binary tree can have maximum two nodes, left node or right node. Okay, now continue.
After finishing the operation, that is the A plus B part, we have again a operator, that is the division point. So the division point, for that division operator, sir, we create these plus and minus one as the subtrees of the division operator. and we will solve the A into B minus C bracket part in the second subtree of division part.
Okay, good. Okay, let me solve. You are absolutely right. So I'm just solving this question for the mother students as well, so they can understand properly more. So let me just. Oh, what is the expression A plus B? A plus B, that is put in, that is already into the bracket manner. And what is the next part? Divide by in the bracket A into B minus C and then plus D. Then a question comes in our mind, sir, which part to be evaluated first? So that part we need to keep in mind. So these are the two different parts, A plus B and A into B minus C are into the form of the bracket we have. So as per the operator associativity. Okay, so precedence, operator precedence, we need to take the first operator, that is the first symbol what we have the bracket. So bracket part will be executed first. So while solving or while evaluating any expression, so we need to go through that part. As we know, this operator is just having the high priority and this is just having the minimum priority. So you can take this part, you can take this part. So what A plus B, how you can represent A plus B? A is our operand and B is our operand, and operator will be represented by the form of the internal node. So plus I can note that over here. So I'm just putting into like this one. So this could be what? This could be our tree. Can I write this one? A plus B, can I write like this one? Now tell me.
Yes, sir.
Okay, thank you. And what happened? A plus B. So A into B, sorry, A into B and minus C. So which is the which operator is having high percentage? Definitely multiplication. So A into B will be evaluated first. Okay, so A into B I can take like this one. So multiplication operator, that is the star or asterisk symbol over here. So can I do this like this one? Can I do like this one?
Yes, sir.
But till now this expression not evaluated, or this part bracket part is not evaluated so far. So C will be our leaf node, and this would be the solution of this. Here we will get the solution and will be connected by the like this one minus. So I can say this is the correct answer. Now is it okay? Did you get what I'm going?
Yes, sir. Yes, sir.
Okay. And now you can note it down over here. This division operator now plus I have, and D is basically I'm just writing D over anywhere. So D I'm just putting over here. Okay. Now question comes in our mind, sir, which part to be evaluated first? Definitely this part. Division part will be evaluated first. So I can take division operator over here and then connect with is like this. Okay, and then plus will be evaluated at the last. So this part will be taken. Now this is a solution of the our expression into the expression T, and this is known as the expression T. Now is this clear to all that what how we are going through? Is this okay?
Yes, sir.
Okay. Do you have any problem over here? Then you can ask. Tomorrow we will also solve any question, any other more questions regarding this one. So this is the expression tree, and I will give you 2 or 3 examples regarding them. During the class time, you will solve this question tomorrow itself again. And this is the example I have. So this kind of example we will take tomorrow. And tournament tree. So tournament tree basically a theoretical concept. So okay, tomorrow I will explain tournament tree. A tournament tree is not a necessity for the understanding the data structure. Basically, it is a representation only, and it can just maintain the records like a tournament. Okay, like the playing the chess, playing the cricket, and who will win the match, who will lose the match. So this kind of the situation you will keep in mind in form of the tournament, and definitely the we have the some leaf node and some things internal nodes, and that is also represented by the some leaf node or internal node, and who will win and who will lose. And to representation of this kind of tournament, we will represent like the tournament tree. And tournament tree, you can have example where we are just dealing with the tournament like cricket. So in the Super Six, which team is coming and who will win the match and who will lose the match. So definitely the match between the two different countries. Okay, playing the team, two different teams are two different team are playing a cricket, and who will win the match, who will the loss. So definitely the team which will win the match will jump into the our and its upper part, and then its sibling team. Sibling team could be anyone, so definitely, it just take any match between the two different siblings. So it's just representation of the information in form of the tournament. So we have the tournament tree. Practically, for the implementation purpose, it is a good thing. So you can take this kind of situation. So here I'm just taking over here. So definitely tournament tree. I will take another example for tomorrow. For the real example, for the cricket example, I will draw on the my page. So I will show with the help of the data. Okay, so this is the just end of the this class. The tournament tree was the last slide. Okay, so here I have downloaded your attendance.